Hello, Dr. Charles. This is Nick Howard doing a demo of my reliable data transmission project. So I'll start by explaining how our nano works. And we're taking power from the nano right here. It's a 5 volt. And we're connecting to ground. And we're bridging our power across here. This is the first thing that we do, and then we add this LED with a resistor, and we plug it in and check it out, and that resistor starts popping on and off. And we start writing a little bit of code, for the transmitter. This is the full code right now, but I'll get to that in a minute. Oops, my triple wire got disconnected. The next part is really carefully analyzing where your pins go for the LCD screen. D4 to D4, D5 to D5, D6 to D6, D7 to D7, and then you have the register select. All right, and that's going to go over to the variable resistor. And we have the enable pin, which it looks like it goes all the way over to, I believe, 9. And the read write pin is going to come over to 8. So then those are our relevant data pins. And then we have the cathode, which goes to ground, and the anode, which goes into a resistor. So then we got power. But that RS switch will decide our contrast. And then we have basically everything we need to start thinking about the code that we would put, and it would, we want to send some bits. And so I have the full code here, but I guess I'll just kind of go over it. So we define our pins, and of course I have the clock data here already, but like I said, it's the full code. And this is the message I want to send. And this is our setup code. This is going to be an output. This is a transmitter. It's going to initialize the LCD pins. And then initialize it and begin the LCD and set our cursor to the 0, 0 in the first part of the 2-part LCD screen. And then print it out. Let's see, character at a time. So then we use like the byte index to grab bits at a time and load them into the TX byte. So basically we're iterating bits into a variable to build up a byte of 8 bits and then display it according to the ASCII chart. I did get that far. Plug this in. All right, got the cursor that keeps track of the byte as it goes through. It's working just fine. So then it's time to build our other board, which I built the other board, soldered it and everything. So when it was time to, and I wrote a little bit of code to make sure that the receiver was waiting, is listening on something, but it wasn't ready yet. And to get to the point where we were ready, he attached 2 power sources here, and I had bought this guy. And I messed up. And I ran these two into my respective positive negatives, and I blew my computers. So 2 of my nanos are blown, or overheated, I mean. And I had a spare one, or else I wouldn't have been able to show you this today. So, though I can't show you the final product, I could still go over what it would be. So, we had first connected just the yellow and black, and the yellow was connected to the transmitter pin, which was our first little LED pin. And we're sending output from the red LED to the green. The red is output, green is input. And what happens is we get a crazy delay, and the screen doesn't quite display I'm sorry, the receiver doesn't quite display because of the clock signal, because of the delay is, no matter how good you are at pressing both of them at the same time, there will almost always be a delay just because of error. So the idea is to first go into transmitter and build some type of clock pulse. Let's see. So we pulse the clock, then we delay, and we pulse the clock low. And of course, this is after a delay after our first write. So the transmitter does the first pulse clock high, delay, pulse clock low, and finally Texas data goes so low. And at the end of this should be outputting. The data transfer should be done of the particular byte at that point in transmitter. But of course, the harder thing to understand is what is happening inside of receiver. And so now we receive data, receive clock. Our global pens, since we're going to use timer interrupts, we make sure that they don't optimize our global variables, because we don't need that. We're going to be using timer interrupts, and we don't want to mess anything up. This is kind of just a message that eventually we display. Like, let's go Celts. Oh yeah, and the global, the liquid crystal initiation of the pens is global this time, so we can access them throughout our program. So let's see, this is probably the really important one. Attach interrupt, digital pen to interrupt, RX clock, on clock pulse rising. So we've got on clock pulse right here, and we're going to call that function, but only if RX clock is going from 0 to 1. That means we got data. So if we did, we go into the pulse, and the pulse now goes through the loop that initially we had just put in the regular loop. But now the clock pulse is going to wait until RX is actually trying to write data, and then it's going to get the data, and then it's going to shift the bit position, and finally update the LCD as true. So when the LCD is true, we go to the regular loop, and the LCD goes through the updates phase, and it prints out our bytes. So I want to say that is about it. There's not much else really to go over. The clock signal is now, we add this, and this little green wire, it goes to pin D2. Remember, D3 was transmission, now D2 is clock. And so we plug this in, as well as on the D2 over here on the transmitter line. We plug those, and it's basically over. I've already executed my code. All the code is working fine. I just didn't have a chance to test it because I burned out 2 of the nanos. I believe it was a good learning process, though, and I'm really glad I got an opportunity to do this. Thank you for everything. I'm waiting on 3 more nanos that I should get tomorrow, and if you would like to email me to see if I got the result, that'd be great. If not, all the best. Merry Christmas, and thank you for everything, Dr. Charles.